Hi guys, let's consider a function y of x given by the equality on the board. We need to find y prime, and we know that y is a function of x. Basically, we could have found explicit expression for y and then differentiate it as usual. But as we can see, we have a tangent of y times x and y squared, so this will lead to some difficulties. Instead, we have another option. We can differentiate both parts of this expression. Let's do so. Derivative of 3y minus y squared equals derivative of 5x minus tangent of y times x. We'll begin with the left part. Derivative of 3y minus y squared is derivative of 3y minus derivative of y squared. The first term gives us 3 times y prime, and here we have derivative of a squared function, which is 2y, and we multiply it by the derivative of the inside function, y prime. Now let's have a look at the right part. Derivative of 5x minus tangent of y times x. The first addend gives us just 5. And here we have the tangent of y times x. This is a composite function, so to find this derivative we need to apply the chain rule. First goes the derivative of a tangent. 1 over cosine squared of y times x. And now we multiply it by the derivative of the inside function, y times x prime. This gives us 5 minus 1 over cosine squared of y times x. And in braces we have a product, so to find this derivative we need to apply the product rule. It goes like this: y prime times x plus x prime times y, which is just y. Now let's rewrite our equation. On the left we have this expression, 3y prime minus 2y times y prime equals this expression. 5 minus y prime times x plus y over cosine squared of y times x. All we have to do now is to solve this for y prime. Let's move all the addends with y prime to the left part of the equation. Y prime times 3 minus 2y plus x over cosine squared of y times x equals 5 minus y over cosine squared of y times x. Finally, y prime equals 5 minus y over cosine squared of y times x divided by 3 minus 2y plus x over cosine squared of y times x. So here we found y prime, the derivative of a function which was given implicitly. Our task is complete.